In 3.2, we're going to be looking at solving linear inequalities. So down here, a linear inequality is just like a linear equation, and it has all the same properties, except a linear inequality is going to have the greater than, less than, greater than or equal to, less than or equal to signs in place of the equal sign, just like this. So you're going to see these instead of an equal sign. And sometimes you could see, like I've said before, the not equal to, but I doubt that that'll come up. But just in case, that is technically an inequality as well. So let's take a look at part A. So suppose that two numbers Q and R are related so that Q is less than R. So this is saying that Q is smaller than R. Okay, so that's what that says. Locate points to represent the numbers Q and R. When both are positive, both are negative, one number is negative and the other is positive. So what I want us to do here is to generate three number lines graphing Q and R in those three instances. So go ahead and try this on your own and then come back to the video and see how you did. So for example, we have our three number lines like this, and then you would describe or show where Q and R are located according to the number line. So if you haven't tried it, pause it and try it again. But on number 1, it says Q and R are both positive. So Q and R are going to be on the right side, but since Q is smaller, it would look something like that. So Q is going to be to the left of R because it's smaller. Both of them are negative. So Q and R would look like this. They're both smaller, but Q has to be to the left, so it's further away from 0 in this case for it to be, so it's still smaller. So you notice that there are opposite properties here, whereas for a number to be small and it's positive, it has to be really close to 0. For numbers to be small as negative, the further away from 0 it is, the smaller the number itself is. And then on 3, one number is negative and the other one is positive. So in this case, Q has to be the negative number and R has to be the positive number in order for that statement of Q is less than R to still be true. And let's take a look at B. It says again, suppose that Q is less than R. So Q is still less than R. And so on this, what you're doing is you're completing each statement. You're putting in a greater than or less than symbol in there for each one of these to make it true. All right, so go ahead and copy each one of these in your notes, and then go ahead and put a greater than or less than sign in there. And then if you need to, check it to make sure. Remember, in all of these, Q has to be less than R. And see if you can't come up with a definitive way to determine what inequality is going to go in there. But go ahead and try these on your own. So here we have them all written out. Let's go ahead and focus on one at a time. On this first one, you should have had that the left side is less than the right side. So no matter what you plug in for Q, if you're adding the same amount to both sides, it's not going to change it, no matter what. Same thing on number 2. If you subtract the same amount from both sides, but I guess these are different amounts, so this is going to be less anyway because this is a bigger negative. So it's not the same amount, but because this is a bigger negative, it's not going to change anything. The left side is still going to be smaller than the right. And then on number 3, you notice you're multiplying both sides by the same thing, so it's going to keep it true. This side is still going to be less than the right side every single time. On number 4, you're multiplying each side by -6. Okay, initially we would think, hey, that's going to be the same thing, but you can check it. So if Q is less than, so let's say we have even, if we plug in a number, like let's do 1 and 2, Negative 6 times 1, negative 6 times 2. Is this a true statement? So you have negative 6. And if we were to put less than in there, you'd have negative 6 is less than negative 12. And that is not true because on a number line, negative 12 is over here, negative 6 is here. And so when we multiply both sides by a negative, you notice that inequality needs to flip. So we're going to flip that so that it's the left side is greater than the right side. So when we multiply both sides, we can see by a negative that flips your inequality. Because originally, remember, it was the left side is less than the right side. Q is less than R. If we look at 5, we're dividing both sides by 5. And we're not multiplying or dividing by a negative. So that should keep it so that it's a greater than, but we can test it, right? 1/5. Is that still greater than 2/5? And if you look at a number line, here's 0, here's 1/5, here's 2/5, so it's still true. Okay, so we can divide by a positive. That's not going to change the inequality. What if we divide by a negative on number 6? Well, again, you have negative 1/3, negative 2/3, and on a number line, negative 1/3 is actually bigger because it's closer to 0. So in that case, it flipped. So when we divided by a negative, it also flipped the sign. So in part C, it says, what do your results from all of this work suggest about how working with inequalities is similar to and different from working with equations? So go ahead and take a minute and answer this question in your own words. In your own words, how is it different or similar to working with equations? So in your words, you should have said something about everything else. Everything is the same except for when you multiply or divide by a negative number, then it just flips that inequality. And the reason for that is that, hey, on the left side of 0, the properties are different. Whereas if I have a really big negative number, that's actually smaller than a really small negative number versus a really large positive number and a really small positive number, right? So in this case, negative 100 is actually less than negative 1, but in this case, 100 is greater than 1, right? So we have to flip the signs. And these signs are both the same, but you notice 100 is on the opposite side. Here, 100 is on the left side. Here, 100 is on the right side. So if we were to flip it, it would look like this. So you have negative 100 is less than negative 1, and then 100 is greater than 1 on the opposite side. So that's why we have to flip those inequalities. So go ahead and go through and solve these. When it says use symbolic reasoning to solve each inequality, it just means to go through and solve. For example, let's do the first one together. So go ahead and write this first one, 3x plus 17 is less than 47 in your notes. And once we have it in our notes, if we remember that we treat it exactly the same as an equation, except for if we multiply or divide by a negative, the inequality flips. We can set it up just like an equation. So subtract 17 from both sides, and you would have 3x, and on the other side you would have 30, and then divide each side by 3, and you would get x is equal to 10. But with the inequality, instead of the equal sign, we're going to plug that inequality back in. And we didn't, so right here, we did not multiply or divide by negative, so I know my inequality stays the same, and so that's my answer. And when we go to graph it, keep it simple, right? So you have 10, and if it's less than, it's an open circle because it does not include 10, and it's less than, all numbers less than 10 are to the left of 10, so we put our arrow pointing to the left. Go ahead and try the rest of these, 2, 3, 4, 5, and 6, and then come back to the video to see how you did. So looking at D2, you would add 9 to each side, divide by 8, you should get x is greater than 6.5. Now let's take a look at D3. So in D3, when you go through and solve it, you actually end up dividing by a negative right here. And so when we divide by a negative, we need to flip the sign. So originally the sign was less than, but I changed it to greater than at the very end. Now let's take a look at the next one, D4. So on D4, I do 2 steps at the same time. First thing is I subtract 5x from each side, and then I add 23 to both sides, and that gets me to just the 9x is equal to 36. Then you divide each side by 9, and you get x is equal to 4. But remember the inequality, and right here we multiply it by a positive, so our inequality remains the same. And then let's take a look at number 5. And when I look at this one, I look through my steps. The first thing I do is I subtract 2 from each side, and then that gives me here 16 is equal to negative 4x. Then I divide each side by negative 4, and then that gets me negative 4 is equal to x. But remember right here, I divided by a negative, so I know I'm going to have to flip my sign. So my final answer is going to be x. Instead of it like this, x is greater than, it's going to be x is less than negative 4. If you want to write this with the x on the left side, you can do that. On multiple choice, you're going to see it like this versus like the x on the right side. Okay, let's take a look at the final one here. The only thing different about this one is that we have decimals. So if you want to use a calculator for this one, go ahead and use a calculator, but solving it is exactly the same. Okay, so the first thing I'm going to do is I subtracted 995 from each side and negative 6x, or subtracted a 6x from each side. And when I have, look what I have left, I have 2,980 is equal to 11.95x. And then I divide each side by the 11.95. And you have x is equal to 249.37. However, once we're here, you have to think back, well, at any point in here, did I multiply or divide, which is this right here, by a negative? Nope, that was a positive, so the sign's going to stay the same. So it would be x is greater than 249.3. You can write it like this, or write it so x is on the left side of that inequality, like that. And so then that's going to be our final answer for part 6. And that'll do it for 3.2, solving linear inequalities symbolically.